Solve the exponential equation for x. Now this is crazy. I've like looked at this. I've seen it. Like I can see 3 different ways to solve this. Okay. So I want to start off by this. You guys should know your squareds kind of well. Squareds, and you guys should know your cubes pretty well. Okay. Do you guys know your squareds pretty well? Okay. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Okay, this is pretty, like, right? Okay, what about the cubes, though? I mean, I think that there's a lot of you guys that might not know your cubes very well. Okay, what's 3 cubed? That's 27. Okay, and what's 4 cubed? 64. And 5 cubed is pretty much the last one that you need to have memorized, okay? Is there a 6 cubed? Yes. We can go more, but mostly it's like these numbers you need to have memorized, okay? You should know those ones, okay? And then one more review thing, okay, guys? You gotta do this with me, though. What is 2 squared again? It's 4. And what is 2 to the 3rd power? That's 8. What is 2 to the 4th power? 16. Now there's kind of a pattern happening right here. Every time it goes from 16 to 8 and then 8 to 4. What am I doing every time? Dividing by 2. Okay, so what is 2 to the 1 power? It is 2. Okay, what is 2 to the 0 power? Hey, good job, right? You're following the pattern. You keep dividing by 2. So what is 2 to the negative 1 power? That's 1/2. What? Okay, what about 2 to the negative 2 power? That is 1 over 4. You can also write that as 1 over 2 to the positive 2. So it's almost like this negative 2 went positive when you took the base and put them on the bottom of the fraction. Whenever you change the base from numerator to denominator or denominator to numerator, it changes the sign of the exponent. Okay? So how can I rewrite 2 to the negative 3 without a negative? 1 over 2 to the 3rd, right? Okay, so is that pretty easy? Is that easy? Okay, so there's a neat rule that comes up when you do this. Is like, if you had this fraction right here, and it was being raised to the negative 3rd power, you can do this. 3 over 2 raised to the positive 3 power. Okay, it's a cool trick. You just flip the fraction and it changes the sign. So I'm going to do that over here. Okay, that's the way I'm going to do that. So here we go. We have 3 to the 7 minus 2x equals, and then now it's going to be 27 raised to the positive 8. Now that solves the problem there. We got rid of that nasty, ugly-looking fraction. Okay? Now, but I have another problem. These bases are not the same, so I cannot compare the exponents. I cannot say they're equal or anything like that. Can you guys rewrite 27 with a base of 3? Yeah, what would you write? 3 to the what? 3 to the 3rd. Okay, and now we have a little bit more simplifying to do on the right side. Okay, what do you do with parenthesis exponents to inside exponents? You multiply. So it's 3 raised to the 24. Okay, so now we have common bases. We have the same base here and the same base right here. And this says that the left side equals the right side. Therefore, this should equal this. And so now we set up our new equation. 7 minus 2x equals 24. And then we solve the dude. What do we do first? We subtract, well, you can divide by negative 2, but that makes things more complicated. Let's subtract 7 first. What is 24 minus 7?
21.
Is it? It's 17, right? 17. And then we have divided by negative 2, divided by negative 2. So what does x equal? Negative 17 over 2. And I'm not going to make it into a mixed number. I'm going to leave it like that. Negative 17 over 2.